Welcome to qnawire.
Hi, so for this problem, the first thing that we need to assume is that we are going to have a complete precipitation of our calcium sulfate. And we're going to have our equation for KSP as follows. So let's assume that we have precipitated this completely. At equilibrium, at amount minus S, it is going to be produced. We have a change of minus S, and at equilibrium, we're still going to have a solid. And let's say that we are going to start with a zero amount of calcium 2 plus, and the amount of sulfate, let's say that we can call this X. Okay? So the amount of change that we're going to have, it is going to be plus S and plus S. So that at equilibrium, we're going to have S and S plus X. Okay? So now, let's look at what the problem is actually asking. We're starting with a solution of calcium 2 plus, which contains 10 millimole in 100 milliliters. This is equal to having a concentration of 0.1 molar. If you have millimole per milliliter, you can divide it directly because the conversion factor from millimole to mole and from milliliter to liter are going to cancel out. So we're going to start with a concentration of 0.1 molar. We need to convert everything into concentrations in molarity because the KSP is given by the concentrations in molarities. Okay? So that is the starting point. So we want at the end a 99.9% of precipitation. Thus, out of all of this amount, we want 0.999 times that concentration to precipitate. And if we subtract the initial amount minus the amount that precipitated, we are going to get that at the end, the concentration of calcium 2 plus needs to be 1 times 10 to the minus 4 molar. Okay? Now, if we look back into our ICE table, you are going to notice that this problem is equivalent as setting S as 1 times 10 to the minus 4. And the quantity that we need to solve for, it is going to be X. Of course, this is going to be in molarities. Okay? We can do some approximations, but first off, let's do the whole problem without doing any approximations. So KSP for this compound, it is going to be the product of the concentrations of calcium 2 plus times the concentration of sulfate 2 minus, which from our equation is going to be S and S plus X, because we assumed that we had to add more sulfate in order to have a 99.9% of precipitation. You can also verify that directly by taking the square root of the KSP and convert that molarity into amount of millimole that you are going to have in your solution, and you're going to notice that just the quantitative precipitation it's not going to be enough. Okay, so the value for S, we said that it needs to be 1 times 10 to the minus 4 molar. So KSP, which is 6.1 times 10 to the minus 5, it is going to be equal to 1 times 10 to the minus 4 times 1 times 10 to the minus 4 plus X. In this point, we could approximate this as being approximately equal to X, or we can solve the full equation. In both of the cases, you're going to get super close results. For example, solving for x with the full equation with any approximation gives an x equal 0.61. Well, actually 1699 molar. Okay, and doing the approximation, the result is the same, 0.61, and it's quite direct. Okay, so in this case, it really doesn't matter. You can use approximation or solve the full equation. Let's stick with this value. We know that that is going to be the value for x, and x was the amount of sulfate to minus that remained after precipitation. Okay. Now, the other thing that we need to take into account is that that is in concentrations. So we need to convert 0.61 moles per liter into the amounts of millimole that we need to add. So the amount that remained after precipitation, it is going to be the concentration times the volume of the solution, which is 0.1 liters. We have a 100 milliliters solution, and then we need to convert mole to millimole with this conversion factor. 1000 millimole corresponds to 1 mole. And with this, the result that we are going to find, it is going to be 61. And careful here, this is millimole after precipitation. Okay. After precipitation of sulfate. Okay. So now what we need to take into account is the amount that reacted. So the amount that reacted in parentheses that formed a solid, it is going to be, if we take it like formally, it would be 10 millimole times 0.999 to take into account the 99.9% of precipitation that we had, right? So this would be 9.99 millimole that reacted. Okay, so if we add up the amount that reacted of sulfate reacted plus the amount after precipitation, that should be left in order for the solid precipitation. This would give us 9.99 plus 61 millimole, which is 70.99 millimole, which is close to 71 millimole. And that would be the total amount in millimole that we need to add in order to precipitate 99.9% of the calcium.